Artificial intelligence is transforming our world. But how exactly do these intelligent systems learn? Today, we're diving into the essential process. What is AI training? AI training is the fundamental process that enables machines to learn from data, recognize patterns, and make informed decisions or predictions. To start, artificial intelligence is the umbrella concept of creating intelligent machines. Machine learning, or ML, is the primary technique used to achieve AI, specifically through training models with data. The core purpose of AI training is simple: to transform raw data into a functional model that can perform specific tasks, whether it's identifying objects in images or predicting market trends. The training process is a systematic, multi-step journey. Let's break down the key stages involved in building a reliable AI model. It all starts with data collection. AI thrives on vast, diverse data sets, whether it's millions of images, lines of text, or numerical records. The quantity and quality of this data directly influence the model's performance. Next is data preprocessing. Raw data is often messy. This step involves cleaning the data, handling missing values, and formatting it consistently. For supervised learning, this is also where data is carefully labeled. Before training begins, we select the appropriate model architecture or algorithm. This could be a complex neural network for deep learning or a simpler model, depending on the problem we are trying to solve. Training is rarely a one-shot deal. It requires continuous iteration and optimization to achieve the best results. The prepared data is fed into the model. The model processes this information, adjusting its internal parameters, or weights, to learn the underlying patterns and relationships in the data. Hyperparameter tuning is crucial. These are external settings, like the learning rate, that are adjusted based on how well the model performs. It's about finding the sweet spot for maximum accuracy and efficiency. Loss functions measure the error in the model's predictions. Gradient descent is the optimization algorithm used to iteratively reduce this error, ensuring the model's weights move in the right direction toward better performance. Once the model has been trained, validation and testing are essential to assess its true capabilities. We use a separate validation dataset to monitor the model's learning progress. This prevents overfitting, which is when the model performs perfectly on training data but poorly on new, unseen data. Finally, the model is tested on a completely independent test set. This final evaluation confirms its real-world accuracy and how well it generalizes to new situations. There are several main paradigms for AI training, categorized by how the data is presented and how the model learns. Supervised learning uses labeled data. Think of it like a teacher guiding a student. The model learns by mapping input to output, based on examples where the correct answer is already provided. Unsupervised learning involves training on unlabeled data. The goal here is for the model to discover hidden structures or patterns within the data on its own, often used for clustering or anomaly detection. Reinforcement learning is based on a reward system. The model, or agent, learns to make a sequence of decisions by interacting with an environment, receiving rewards for good actions and penalties for bad ones. AI training is a complex, iterative process that constantly drives technological innovation. AI training is not a one-time event, it's a continuous cycle. As new data becomes available and performance needs change, models are continually retrained and updated to stay relevant and accurate. From gathering data to rigorous testing, AI training is what gives intelligent systems their power. This process ensures machines can adapt, learn, and contribute to solving some of the world's most complex problems.